Okay, students. So, in the lesson, we discussed the two types of bonds, ionic bonds and covalent bonds. And before that, we tried to understand why atoms need to form bonds. You know the reason. They need to attain the noble gas electronic configuration, which is a stable electronic configuration. And also, when there are 8 electrons completed in the valence shell, we call it the octet configuration. To do that, they can either lose and gain electrons, that is, one atom loses, the other one gains. So, thereby forming the positive and negatively charged ions, and the attraction between the ions is known as the ionic bond, which gives rise to the ionic lattices. On the other hand, when atoms share electrons among themselves or with other atoms of different elements, they form covalent compounds. So, there are homoatomic molecules which are found in elements as well as heteroatomic molecules which give rise to compounds. Then we saw that under covalent compounds, there are atomic lattices. The allotropes of carbon exist as atomic lattices. Other covalent compounds exist as molecules. And then we discuss how we can draw the structures for these covalent molecules. That is the Lewis dot cross diagram, Lewis dot diagram, and the Lewis structure. Thereafter, we discuss the intermolecular interaction and polarity of bonds. And also, we compared the properties of ionic compounds with covalent compounds. So, now that we have a good understanding about the lesson, we will answer the questions. I will start off with the questions given in your textbook, that is grade 10, unit 10 exercise. And the first question that is given to you is define an ion. So, I am sure you have already answered the question. If not, you answer it by yourself and then listen to the discussion. So, define an ion. What is an ion? Ion is an atom or a group of atoms that has an electric charge. So, that is what is an ion is. Ion is an atom or group of atoms with an electrical charge. So, here that is what we have to write. We don't have to give any examples. Ion is an atom or a group of atoms with an electrical charge. So, with that, I will move on to the next question. Write the electronic configurations of the following ions and illustrate them by diagrams. So, you need to write the electronic configuration and then illustrate them using a diagram. So, here, if we take the first one, that is Na+. You can remember, students, sodium, the atomic number is 11. So, 281 is the electronic configuration. From that, the one valence electron is removed from sodium atom, forming the Na+ ion. So, here the electronic configuration becomes 2,8, similar to neon, the noble gas. So, we have to represent this using a diagram. To do that, that is the nucleus. Then I will draw the first energy level and the second energy level. And to denote the electrons, I will use a different color. You can use the same color, fine. In the first energy level, there are 2 electrons. And in the second energy level, there are 8 electrons. 5, 6, 7, 8. And usually, we show the electrons as paired electrons. Is that okay, students? So, that is for sodium ion, Na+ ion. Then we have magnesium ion, that is Mg2+. Again, if you remember the atomic number of magnesium, that is 12. So, electronic configuration 2, 8, 2. And it belongs to group 2, valency is 2. The 2 electrons are lost from the magnesium atom to form the magnesium ion. So, what is the electronic configuration there? That is also 2, 8. Again, similar to neon. So, we have to represent that also using a diagram. So, here again, if I draw the nucleus, then the 2 energy levels, and then we can denote the electrons. In the first energy level, there are 2 electrons, and in the second energy level, there are 8 electrons. And as I told you all before, we pair the electrons. So, can you see 2 in the first energy level, 2, 4, 6, 8 in the second energy level. So, those are the ions. And normally, when they have a charge, what do? We write square brackets. If you can remember, when we denoted the ionic compound, we use square brackets and we can denote the charge. So, sodium has a positive charge. So, this indicates it is the sodium atom with a positive charge. Whereas magnesium has 2 positive charges, 2 plus. So, sodium plus, that is magnesium 2 plus. Is that okay, students? So, then I will move on to the next one where we have O2 minus, oxide ion. Oxygen, you all can remember, students, atomic number 8. So, 2, 6 is the electronic configuration. But here, oxygen atom takes up 2 electrons or gains 2 electrons and forms the oxide ion. So, therefore, the electronic configuration becomes 2, 8 when there is 2 minus charges. Again, similar to the neon noble gas. So, if we represent this in a diagram, what do? We have the nucleus in the middle, first energy level and the second energy level. So, if we show the electrons in the first energy level, there are 2. Students, when you all are drawing the diagram, I am sure you can draw very nice circles. And you know, the first energy level is somewhat far away from the nucleus. And as you go away from the nucleus, the energy level come closer to each other. That's how we draw the energy levels. We have discussed that before. So, for oxygen, in the second energy level, again there are 8 electrons. And we usually pair these electrons. 8 electrons. So, is that okay, students? Then what do? We need to indicate the charge. Use square brackets and put 2 minus there. So, that shows this is the oxide ion with 2 negative charges. That's why the shells are all complete. Energy levels are complete. Then we have nitride, N3 minus. Again, nitride. Recall the atomic number 7. So, electronic configuration 2, 5. Because it has 3 charges, that means it has taken up 3 electrons. So, the electronic configuration of the nitride ion is again 2, 8. 2, 8. So, that also has complete shells and that also 2 shells. So, the nucleus, then we have the first shell and the second shell. If I denote the electrons there, in the first one, there are 2 and in the second energy level, again there are 8 electrons. So, this has 3 negative charges. So, now can you all see, students? The 2 ions that we drew first, sodium, magnesium. I will go back to the previous slide. Here you can see after losing, they have obtained the noble gas electronic configuration. So, here you can see they have complete shells. So, that is a stable electronic configuration. And they all have the same electronic configuration 2, 8, similar to neon. The same goes for the negative ions as well. O2 minus and N3 minus. They also resemble neon. So now, can you all understand? They all have the same electronic configuration or stable electronic configuration as the noble gas neon. With that, I will move on to the next question. What is meant by an ionic compound? What is an ionic compound? When there is a rearrangement of electrons, one atom loses, another atom gains, there are ions formed. And the electrostatic attraction between these ions is known as the ionic compound. So we have to write that down as the explanation for ionic compound. So if we write that, the electrostatic attraction between positive and negative ions formed by the rearrangement of electrons between atoms is known as ionic compound, ionic bond. So here students, the question is what is meant by ionic bond? The electrostatic attraction between positive and negative ions formed by the rearrangement of electrons between atoms is known as ionic bond. So that is the explanation for ionic bond. With that, the next question, illustrate by diagrams how the compound calcium oxide is formed. So from the elements calcium oxide, you all should know students, this is an ionic compound. Why? Calcium has very less electronegativity, whereas oxygen has somewhat high electronegativity. So it's easy for calcium to lose electrons and form the cation, whereas oxygen forms the anion. So it has to be an ionic compound. Then if you take the valency, now calcium is 22, 8, 8, 2. That is the electronic configuration, so valency 2. And if we take oxygen, 8, that is 2, 6. So there also the valency is 2. So when calcium loses 2 electrons, those 2 electrons can be taken up by oxygen. That is how the ions form, rearrangement of electrons. So there, illustrate by diagrams how the compound calcium oxide is formed. So here it is the calcium Ca2 plus ions. They will have 2, 8, 8 electrons, whereas O2 minus ion will have 2, 8 electrons. That is what we have to show as the diagram. So there, if we draw the nucleus of calcium, first energy level, second energy level, and we need to have the third energy level. And here, if I denote the electrons, in the first shell, there are 2 electrons. In the second shell, there are 8 electrons. And in the third shell also, we have 8 electrons. So this has 2 plus charge, calcium ion. And on this side, we have the nucleus, the first energy level, and the second energy level of oxygen. So how many electrons? 2 electrons in the first energy level and 8 electrons in the second energy level. Here you can see 8 electrons and there are 2 negative charges, 2 minus. So here can you all see, students? Calcium 2 plus 2, 8, 8. So 2, 8, 8 and it has 2 plus charges. Oxide 2, 8 is the electronic configuration that has 2 negative charges, the cation and the anion. And the attraction between the cation and the anion is the calcium oxide compound, an ionic compound. Is that clear to you all? So this is how we illustrate by diagrams how the compound calcium oxide is formed. Is that okay, students? So with that, I will move on to the next question. So the fifth question, draw the dot and cross diagrams of the following molecules. So the first one is chlorine. So you all know chlorine is a Cl2 molecule. It's a homoatomic molecule. Why? Chlorine is an element. So it is Cl2 gas. We need to draw the dot and cross diagram for the following molecule. So what do you need to show here? Chlorine atom, another chlorine atom. In a dot cross diagram, students, you all know we only consider the valence electrons. So in a chlorine atom, how many valence electrons are there? Normally, the atomic number 17, so 2, 8, 7. There are 7 valence electrons. That is what we need to show here. We use dots for the electrons of one chlorine atom and crosses for the electrons of the second chlorine atom. So then, for the bond, we need to use a dot and a cross. Then I will take the dots for this chlorine atom. There are 3 electrons that exist as non-bonding lone pair electrons. You can remember that. Then the second chlorine also has 3 pairs of non-bonding lone pair electrons. So here 3 pairs of crosses. So now count and see 2, 4, 6, 8. Octet has been achieved. And this chlorine also 2, 4, 6, 8 octet has been achieved. And this is the bond pair electrons. This is for you all to recall what we have learned before. So this is the dot cross diagram of chlorine. Then for oxygen. What is oxygen? Again a diatomic molecule, an element. So here it is O2 gas. So there also we need to have 2 oxygen atoms, and you can remember, students, the valency of oxygen is 2. So it needs to form 2 bonds. It has only 6 electrons in the valence shell. It has to form 2 bonds in order to achieve the octet electronic configuration. So then we need to show 2 pairs of bonded electrons or 2 bond pairs of electrons. So a dot, cross, dot, cross. So one pair, the second pair. Then how many electrons are there as non-bonded lone pairs? There are 2 pairs. So 2 pairs of non-bonded lone pair electrons. And on this oxygen also there are 2 pairs. Now if you count the total number 2, 4, 6, 8. So octet has been achieved. And on this side also 2, 4, 6, 8. So there is a double bond between the 2 oxygen atoms. You all can understand that. Chlorine, chlorine single bond, oxygen, oxygen double bond. So with that we will move on to the next one, water. So you all know the chemical formula of water, that is H2O. So to draw the dot cross diagram, what do we do, students? You all know oxygen is the central atom and we have the hydrogens, and with all the understanding you have, you all know oxygen and hydrogens, they form an angular shaped molecule. Water is an angular shaped molecule. Why? Because there are lone pairs, That also you know, and the polarity of the bond. So then we need to show the bonds. So here we can use the dot 10 cross for the OH bond, again dot 10 cross for the other OH bond, and there are 2 lone pairs on oxygen. Why there should be 8 electrons. So here the 2 lone pairs. Is that okay? Water molecule. Then we have methane. That is CH4. So there the central atom is C. And there are 4 hydrogens. And the valency of carbon is 4. So it has to form 4 single bonds. Hydrogen anyway forms 1 single bond. So we use dot n cross, dot 10 cross, dot 10 cross, dot 10 cross. So that is the methane molecule. 4 CH single bonds. Is that clear to you all students? So in all these, you can see we only show the valence electrons, and you need to have an idea as to whether the bond is a single bond or a double bond, or how the molecule is, whether it's angular, or how we arrange the atoms. I told you all we have to arrange them in a manner so that there is somewhat symmetry around the central atom. So here you can see central atom carbon. We have arranged the 4 hydrogens in a way that there is symmetry between the atoms, and the electrons are distributed nicely. Is that clear to you all? So water and methane. Then we move on to the last one, that is ammonia. So in ammonia you can remember NH3. What is the central atom? It is nitrogen. So we have the 3 hydrogens like this, and you can remember nitrogen valency 3, but it has 5 electrons in its valence shell. So that means there are 3 single bonds, NH bond, then we have another NH bond and the other NH bond. Then if you count the total number of electrons, 2, 4, 6. There are 2 more electrons. So they exist as a non-bonding lone pair of electrons on nitrogen. So when you count the total number of electrons, hydrogens have 2 electrons each. So they have the complete first energy level. Then when you take nitrogen, 2, 4, 6, 8, octet is satisfied. Is that okay, students? So those are the dot cross diagrams of the molecule. I am sure you also wrote them correctly. So with that, I will move on to the next question. What is meant by a covalent bond? So what is a covalent bond, students? Joining of atoms by sharing electrons between a pair of atoms. So that is a covalent bond. So we can write that down. Joining of atoms by sharing electrons between a pair of atoms. So always when a covalent bond forms, there are 2 atoms, a pair of atoms, and between them there are electrons being shared. So it can be a single bond, double bond, or a triple bond. But when they share the electrons, that is sharing the valency. That is why we give the name covalent bond. So sharing of electrons has to be there. So this is how you explain what a covalent bond is. Joining of atoms by sharing electrons between a pair of atoms. Is that okay, students? So then I will move on to the next question. Give 2 properties of ionic compounds and covalent compounds. Ionic compounds, what are the properties? They exist as crystalline solids in room temperature. Then they have very high melting point and boiling point. They conduct electricity in the fused or molten state as well as the solution state. And they are usually soluble in water, or you can say most of the compounds are soluble in water. So those are the properties of ionic compounds. So here if we write the properties, ionic compounds. So they have asked us to write two properties. So we can say exist as crystalline solids at room temperature. And also you can say they have high melting and boiling points. That is for ionic compounds. You can write any other property as well. Then for covalent compounds. So here the next one is covalent compounds. What can you say for covalent compounds? They exist as molecules that are made up of two or more atoms, and they usually exist as liquids or gases at room temperature. They normally have low melting or boiling points. And some of the covalent compounds are only soluble in water. So you can write any of the properties. And you can remember, students, as covalent compounds, the atomic lattices, those are exceptions because they have very high melting and boiling point. Graphite conducts electricity. So all those are because of the atomic lattice structure. But when we write the properties of covalent compounds, we just stick to the common properties. So here, when we write the properties of covalent compounds, we can say they exist as molecules of two or more atoms. They usually exist as liquids or gases at room temperature. So is that okay, students? You can write any two properties for the ionic and covalent compounds. Here I have written for ionic compounds exist as crystalline solids at room temperature. They have high melting and boiling points. And for covalent compounds, they exist as molecules of two or more atoms, and also they usually exist as liquids or gases at room temperature. Apart from that, you can write any of the two characteristics that I have discussed with you. So with that, I will move on to the next question. Question number 8. Carbon is an element in group 4. Why carbon has a high melting point and a high boiling point? Why does carbon have a high melting and boiling point? What is the reason, students? That is because carbon exists as atomic lattice, and in the atomic lattice there is the strong covalent bond between the carbon atoms, and because of that they have a very high melting and boiling point. And you can remember, if we take graphite, one carbon bonds with another 3 carbons. In diamond, one carbon bonds with 4 other carbons, forming a 3-dimensional lattice. That gives rise to the high melting and boiling point. So that is what you have to explain here. So carbon is an element in group 4. So we can say carbon has valency 4 because it belongs to group 4. Therefore, it forms covalent bonds by sharing 4 electrons. When electrons are shared between carbon atoms, they form large atomic lattice. Within brackets, I can say graphite and diamond. To break all the covalent bonds of the atomic lattice, we need to supply a large amount of energy. Therefore, they have high melting and boiling points. So that gives a complete answer. We will go back and check the answer. Carbon has valency 4 because it belongs to group 4. Or you can just say carbon has valency 4. Therefore, it forms covalent bonds by sharing 4 electrons. And when electrons are shared between carbon atoms, they form large atomic lattice. That is the graphite lattice and the diamond lattice. And to break all the covalent bonds of the atomic lattice, we need to supply a large amount of energy. Therefore, they have high melting and boiling points. Is that clear to all students? So, I am sure you also would have written a similar answer, but make sure that you include all the points there. So, with that, I will move on to the next question, that is question number 9. Explain scientifically why common salt is readily soluble in water. Why common salt is readily soluble in water. Now, if we take common salt, what is that? That is sodium chloride. It is an ionic compound made up of Na plus and Cl minus ion. So it is an ionic compound. And what about water? Water, H2O, is a polar molecule. So what happens there? When you take, now normally in a solid of sodium chloride, the positive and negative charges are all fixed. Now I am explaining what happens there, student. And if you take water, they exist as the angular shaped molecule, but they have poles. Why? This has a delta negative pole, this has delta positive. So the polarity is there. When you mix them together, these two are mixed together, that is sodium chloride dissolves in water. Then what happens? If you take the container, now there is the positive sodium ion that gets surrounded by the partial negative charge of oxygen. So the same way the partial negative charge of oxygen can surround the positively charged sodium ion. The same way the negative charge of chloride ion or negatively charged chloride ion gets surrounded by the partial positive charge of hydrogen. So like this, the hydrogens surround the negative charge chloride ion. So the positive ion is surrounded by the delta negative of water. The negatively charged chloride ion is surrounded by the delta positive. So there is an interaction between the positive sodium ions and the delta negative of water, whereas the negative chloride ion and the delta positive of water. So because of that, sodium chloride ionizes in solution and it dissolves well. So that is what we have to explain scientifically. Here I have explained what happens. Now we have to write down the answer. So this is how you will have to write it. So we can say when sodium chloride solid dissolves in water, it ionizes into Na plus and Cl minus ion. The sodium plus ions are attracted to the partial negative charge on oxygen, that is delta negative, and the Cl minus ions are attracted to the partial positive charge on hydrogen atoms of water. Therefore, sodium chloride dissolves well in water. Is that okay, students? So if we look at the answer, you can see when sodium chloride solid dissolves in water, it ionizes into sodium ions and chloride ions. The sodium ions are attracted to the partial negative charge on oxygen and the chloride ions are attracted to the partial positive charge on hydrogen atoms of water. Therefore, sodium chloride dissolves well in water. Is that okay? So, when we say dissolving and ionizing, because it is able to attract, because there is an interaction or attraction between the opposite charges, it is able to dissolve well. So, I am sure you also can write a similar answer like this. With that, I will move on to the next question, that is question number 10. The last question given in your textbook. Give reasons to the existence of high boiling point, that is 100 degrees Celsius to water, though it is a covalent compound. So you know, normally molecules are there in covalent compounds and there between the molecules there is intermolecular bond or intermolecular forces. And here the intermolecular force that exists between water molecules is somewhat strong. Not strong like covalent bonds, but it is somewhat strong. So, if we want to boil water and convert it to water vapor, we need to break that intermolecular force. So, to do that, we need to supply a somewhat high amount of heat energy. That is why the boiling point of water is 100 degrees Celsius. That is what you have to explain here. Give reason to the existence of high boiling point. So, if we do that, reasons to the existence of high boiling point, you can even show the intermolecular interaction there. There is delta minus, delta plus, delta plus. Then there is another molecule, water molecule, delta minus, delta plus, delta plus. And there is this interaction, intermolecular interaction. Intermolecular bond or intermolecular force, or what you can also call as intermolecular interaction. Then, and you know another name for this is hydrogen bond, but that has been introduced in your extra knowledge part. So, I am not going to use that term here. So, we can say to boil water and convert it to vapor, we need to break the intermolecular bonds. Although they are not strong as the covalent bonds, a high amount of energy, within brackets you can say heat, should be supplied. Therefore, water needs to be heated at 100 degrees Celsius for it to boil. Is that okay, students? So we have explained it. To boil water and convert it to vapor, we need to break the intermolecular bonds. Although they are not strong as the covalent bonds, a high amount of energy, that is heat energy, should be supplied. So therefore, water needs to be heated at 100 degrees Celsius for it to boil. That is why it has a high boiling point. Is that okay, students? With that, I have completed the questions given in your textbook. But in the next chapter, I will be discussing some extra questions with you.